And your saturation is your resource utilization, which is your CPU usage, your memory usage, and your disk usage. So it tells us what is actually for our servers there. So if monitoring actually tells us what is wrong, that something is wrong with our system, you are able to figure out, okay, something is wrong. That means we are reactive. We are reactive to an issue. Today, we are being reactive. After something has actually occurred, it's actually a known issue to you. You actually tell you what's wrong. What's going to tell you why that this thing is occurring? Why is my application having high errors? Why is user complaining that my website is actually slow? But monitoring does not tell you why. So what tells you why? That's when we now come to observability. Observability in practice is collecting all these actionable data and organize them in such a way that gives knowledge of the whole environment, depicting not only when and where an issue occurred, but importantly why it occurred. So in observability, the first step in observing your application is actually collecting what you know as telemetry data, or the three pillars of observability, which is your logs, your matrices, and your traces. So when we define logs is what you know as like the detailed or a series of messages that gives context to an event that is happening in your application or your infrastructure. So you have container logs, you have your server logs. Everything is actually giving logs there. So these logs give context to what's actually give series of messages that are actually happening to events in the infrastructure. The metrics, as I mentioned before, is all these variables or values tied to your resources. Then traces, when we look at traces, you can see traces is it represents the journey of a request and it moves through different parts of your system or your microservices architecture. For example, as mentioned, your e-commerce website, if a user is interacting with your system now, he wants to order a bag in your e-commerce website, he logs onto your web portal, search bag, then that means he has interacted with the search service there. Since everything is actually decoupled, that means it's usually coupled. So it interacts with the search service, then that interacts with the database, which brings up the product catalog of the bags there. So he sees the bags that he wants, he adds it to the cart. So he has interacted with the product catalog service, he has interacted with the cart service. So he checks out that service and pays that service. So all the requests that actually went into that user ordering that bag throughout that process, all the requests joined together is what you know as trace is represents the journey of the request across the entire application. That's what you know as trace there. So gathering all these three together, gathering all this data, this telemetry data into an environment is actually going to give you knowledge of what's actually going on in the system. Deep level understanding that can answer why something is actually wrong with your system. So you are able to figure out what is actually going on. For example, if you have in monitoring, if you have like high latency now, you don't know what is actually going on. Why is actually my website slow? You have to manually start going to your servers or your containers. You start grabbing the logs, start filtering out errors, that what is wrong, what is actually going on wrong. While everything there, you can just go to a simple customer, which I'm going to say, look at the use case of this thing. You can just look at the request of one of the companies that actually happened. Okay, this duration of this transaction is actually slow, and it's going to answer the question of why this actually happens. So the end goal of observability is actually that when there's an issue, there is enough context for you to answer what that issue is, why it is happening there. It gives you enough context. You're able to look at the logs, you're able to look at the metrics. When you look at these metrics, okay, there is high error rates there. Then you look at the logs. Why is this error actually high? Then you can trace one of those transactions that actually brought that error there, which service this thing actually occurred in, to pinpoint what is actually happening at that point. So it answers the question, gives like a deep level understanding of what's actually going on in your own infrastructure there. So as you mentioned, the end goal is to provide enough context for you to resolve any issue and to resolve it very effectively and very fast in the environment. So let's look at observability and monitoring side by side. You have in the data types, monitoring is actually looking at metrics. It's actually looking at metrics is there. While in observability, looking at your metrics, your logs, and your traces. And the approach of monitoring is actually reactive. It's actually what you are setting, your alerts, the alerting system you are setting is what is actually known, is what you actually know that, okay, this is something is going to be wrong if my CPU goes higher than 80%. So when your CPU goes higher than 80%, you are reacting to that issue there. It's being reactive for proactiveness. Whenever you just check your dashboard, maybe you set an interval by yourself that okay, maybe every morning you check your dashboard, you see some spikes and you see some spikes in the error rate, but it has not triggered your alert. So you can see this alert is actually, this spec is actually not normal. In that same platform, you can go and figure out why is actually spikes. So you can look at the transaction that actually occurred during that period of time. You can look at that transaction there, then you can see, okay, this is an issue that I don't know about. This is like a use case that we factored in. You can be able to factor that into your next alert that this is an error that can likely happen. So it's being proactive before a user sees that sort of error there. So as I said, it's for known issues. Why? Because this is for known failure pattern. That's how it works. Then the insights that monitoring provides is for your system and your performance. Is your system working properly? Why? Observability actually performs this deep system understanding. You're able to understand how the customers, how the people making use of the apps, make use of your services, they interact with each and every one of your services, and how they move, the time that they are there from, the time that they are making use of this service, location that they are making use of it from. Maybe it's based on where your latency is actually, maybe based on the customer is actually far from where your server is. Maybe you can they can create resources near the customer. So it gives a deep system understanding of what's actually going on in the system very fast. And example tools for this are the Prometheus, Prometheus, Grafana, Nagios. Then for observability, we have Neuralink, Datadog, and OpenTelemetry. For some time now, I think I've been chance to make use of Datadog and Neuralink can see everything in observability is actually placed in one platform for you. You don't actually have to leave that platform, that window, before you can be able to trace what is actually going on in your system. If there is an error, there are links that still goes and goes on to be able to pinpoint what's actually wrong there. So as I said, monitoring just provides you information about your system, or it provides information. Okay, it gives you like a dashboard. My CPU, my storage is at 80% capacity. My storage is at 50% capacity. I'm having good error on my CPU. My memory is actually at 20% capacity. It's not high. It provides information about your system. Why observability gives you deep understanding. It gives you why this thing is happening. You're able to figure out if traffic is actually low at this point. You can able to figure out why this is actually low there, instead of going through different logging into containers, logging into servers, getting the logs. You are not seeing what's actually going on. You are taking a lot of time to do that. And one of the metrics, like one of the KPIs in let's say DevOps world or SRE world is like mean time to resolve these issues there, so that the customers will not be tired of your service. So it's actually very important to observe what's actually going on in the system. So let's say in real life, so it's not actually about observability versus monitoring. It's how we can implementing the two together, how they work together again. So we can see how it's going to work out in real world scenario. So in the real world scenario now, we've set up automated alerts. We've set up our monitoring system, set up observability. So in your e-commerce website, your automated alerts have set an alarm that your error rate has actually increased from the normal range from 0.2 to actually 5%. And customers' complaints are actually coming that okay, we are not able to check out our products, we are not able to pay the products that we checked out there. So you as an SRE or as a DevOps, you go to your monitoring dashboard, you check out the dashboard, you check out the widgets there. You can see from the way you can see a lot of server errors. That's your 500 5xx errors, a lot of server errors there, and you can see some other errors with it too. But if only just figured out what is wrong with your system. You cannot figure out why this is actually happening. Why do you have a lot of 500 errors there? Why do you have a lot of server errors in this application there? So that's when observability comes in. You can now make use of distributed tracing, whereby you you filter out the time that this complaint of this customer actually comes in, and you filter out the time that the alert actually got triggered. Then after you filter out that time, you can see the transaction that actually occurred during that time. You can take a trace out of this transaction and look at this waterfall diagram, and you're able to trace the request as the move to service. So you can trace this service, then you will not be able to trace that, okay, it is the checkout service and the payment gateway that actually has the error there. You can discover that service A, the checkout service, is sending malfunction JSON. Maybe the JSON is actually not formatted properly when it wants to check out to the service B. The service B is now rejecting it, is sending server errors back, which blows up and returns server errors back to the so the end user, the customer, is not able to make use of this application, and is actually impacting it, and you are able to see this in a unified or a centralized place. You are not going into your content. Everything is actually centralized in one platform for you. So, and this is between minutes. You went from problem detection to your dashboard to see what's going on, and you're able to trace what is actually going on in minutes. So you're able to get all this information together. You're able to get the root cause of why is actually feeling that, okay, it's the JSON payload that is actually not formatted right. It's all this information that you can now escalate to the engineers to fix this issue, and everything happens in minutes there. So the main thing is the time to the resolution. You're able to observe what is actually going on there in that service there. It demonstrates, so this use case actually demonstrates how observability provides context to this. It provides what is actually going on and why it's going on. And you're able to quickly identify and resolve these issues in this sort of system. So why did this microservice architecture or modern infrastructure actually use observability? As I mentioned before, is reduced mean time to resolution there. So observability significantly decreases troubleshooting time by providing context and connections between these service components. So the time that you're able to receive that alert, to check your monitoring dashboard, and to resolve to find the root cause of what's actually happening there, it's actually in minutes, and you are not living anywhere in the platform. That's what this observability platform provides for you. Everything is actually centralized for you in New Relic data. Everything is actually centralized for you to make use of. You're able to detect issues in minutes. You're able to pinpoint issues in minutes compared to just monitoring, where you have to just grep logs and making guesses of what's actually going on, doing try and error to see if this will work or if that's work. We are not understanding the system. But observability makes you to understand how these services interact with each other and how these customers interact with those services. So as I said, it also helps in root cause analysis. You're able to, in minutes, find the root cause. It makes it very effective in complex systems. You are correlating this data, you are correlating the logs, you are correlating the metrics, you are correlating the traces all together in one platform for you across the services infrastructure. And this platform, this platform, have actually integrated AI into some of their platforms. So it can provide AI insight in some of these issues there, which we are going to look at now, how AI is supercharging observability in these platforms. So we have predictive analysis now. So by by after some time, if these issues actually occur, or from the historical data, from your metrics, from your logs, AI is actually ingesting this data and is able to predict future failures before it actually happens. So humans might miss some errors there, or actually if some things are not actually alerted, that it will give you suggestions of, okay, this error is actually happening, future failure that might happen. So you can work on this sort of errors. Then you also have this automated anomaly detection on New Relic. That's a feature on alerts whereby you are not using static thresholds again. You're using dynamic thresholds, whereby it uses machine learning to ingest your historical data, and it looks for the average. It sees the normal behavior of how your application is actually performing. So based on standard deviation that you set, it alerts on different anomalies in your system. If your system is not following its normal behavior, you will get an alert that it has gotten over your threshold, your deviation that you put there. So is the machine, is the AI that is getting the baseline, is getting how your application is normally behaving. So outside of its normal behavior, that's when the AI will start alerting you that, oh, something is actually wrong here, and you should look at what is going on there. Then you can go straight to your observability platform and troubleshoot why this behavior is happening there. So it also reduces alert fatigue in the sense that if an issues occurring over again, it groups that incident or that issue together and makes it as one, that okay, this is a whole issue for you. And if you solve it, all these other alerts will not be triggering. There's By the time you have multiple alerts always bugging you and you see it as a false positive, you see those alerts as a false positive, you tend not to try to look at those alerts too much again. So AI helps in reducing alert fatigue and makes you focus on all these real issues there. And also helps in root cause analysis. It combines all these issues together and is able to figure out from all your data that ingested to, is able to figure out the reason that this issue is actually occurring there. So it suggests the root cause for you in all these platforms of data blog and new reality. So that brings us to the end of observability versus monitoring. You are not actually, it's not a versus, you are combining the two. So observability is more than just monitoring. It tells you, helps us to understand why this is actually happening in your system. And it's essential for all these microservices architecture, complex distributed system or cloud native systems. And things are actually being AI is actually being integrated into these platforms to help in minimizing the time for your troubleshooting, and also helps in making not wasting not looking at not using too much time on your monitoring because you like to focus on other things. So AI is helping to shape the future in this aspect of DevOps. So as I said, the baseline is to ensure maximum user experience. So observability helps in doing that. It helps in understanding how the system works and how it can increase your customer satisfaction for your application. Thank you. And if you have any questions, can ask.
Thank you, everyone. The second speaker is not available. Hello? The second speaker is
Yes.
not available.
It is yes to be available. Yes.
Okay. So I'm just going to share something. Does anybody have any questions from Mr. Ayadele while I'm bringing up my slide? Any questions from Mr. Ayadele?
Yeah, hello, can you hear me?
Yes, yes, you can hear yourself.
All right, thank you very much. Sorry, I have technical issues. I just got kicked out and we join again. Thank you, Aurelua, for that incredible presentation. It's so like very professional and clean. Like I've learned a whole lot of things from your presentation, and I'm really impressed. Right, the second speaker is not on the call. However, joining today is still not been as so much has been achieved already, and I'm so impressed with your presentation, Lua. Right? Do we have any questions from anybody you want to ask Lua? There is a particular area that you want need further clarifications from Lua. Whatever you can drop your you can indicate so that you can ask the question. I have my own question and I want to ask Lua a question, right? My question is any of these tools you have mentioned Datadog and New Relic, right? I want to know if any of them has like before GenAI, we already have this platform, right? Then when GenAI came in, and we see improvement in AI kind of a thing, right? Is there any monitoring tool so far that is majorly use artificial intelligence algorithms to grab metrics and then display metrics or dashboards, just like the way Grafana and Prometheus is, right? Is there any platform like that?
From my experience in New Relic, if from New Relic to actually observe your infrastructure or your applications, they have agents which you instrument you install to your containers, your servers. This actually is actually the one that collects all this data. They collect everything, your logs, your matrices, and also collect your logs, your messages, and your traces. So installing these agents actually collects everything. You are able to instrument it on your application. Really.
Okay,
Yes.
okay. Yeah, there is a lot of talk around the new relic in recent times, and then Datadog as well, right? I don't know. Do they have like a scaling issue with scaling? Because I don't know why um, enterprise enterprise architectures are not like adopting that new relic. Because if I can monitor all my infrastructures and every other thing from an application from one place, there is no point setting up Prometheus, their panels and all that. Is it like a scaling issue or something?
I would say I'm not too sure about why maybe big enterprise are not making use of that. And they might be some of these big enterprise might have their own in-house monitoring tools, maybe like Google. But for Datadog, some might consider price because the from my experience, some of this company actually migrated from Datadog maybe because of the pricing of how these things are priced, maybe like New Relic now. So it might be the pricing structure, or it might be their plugins, how it's actually being instrumented, maybe like Open Telemetry now, um, Kubernetes infrastructure now. Some of these platforms might not actually be able to monitor that effectively. So different factors might actually impact why maybe this enterprise infrastructure are not using it. But I'm not sure on that data. Maybe enterprise infrastructure are not using that.
Okay, yeah, that is interesting. Because setting up all that tools probably there is cost overhead. you know.
Yes.
But New Relic is going to like do it from one dashboard. That's interesting. Thank you very much. So much appreciated. Any other questions? Any questions to everyone? Dekunle Victor, how are you doing?
Good afternoon, sir. I'm good.
None from me. Oh.
All right. When we are doing introduction, you weren't on the call. Dekunle.
Yes, sir.
All right. We've all introduced ourselves, except you. Just your name, your title, and where you are joining us.
Okay. Hey, good afternoon, everyone. My name is Victor Adekule. I'm a front-end developer and I'm joining from this state.
Oh, fantastic. All right. Thank you very much for joining us. This is Income Dev Center. This Income Dev Center is a multi-location based training center that distributed across Nigeria and also in UK. In fact, there is a location close to you. I'm trying to see if I can see.
Can you see my screen?
Yes, I can see your screen.
Yeah, these are the locations for Bincom Dev Center. You have Yaba, Lagos, Ibadan, Oyo State, Kano, Kaduna State, Ijebu, Warri, Delta, the United Kingdom, and also virtually. Those are the main locations for Bincom for now, although we do plan to expand and grow to other nations worldwide. The three main focus of Bincom is build tech talent, enhance tech talent, and build startups. So building tech talent, we have Bincom Academy, Bincom Tech Internship, Bincom Tech Apprenticeship, Bincom Global Tech Program. We also have, for enhancing tech talent, you have Bincom Tech Network, Light Space, which you can rent from us in case you want to do an event, Immigrate Tech Visa, Bincom Mentoring Platform, Bincom Tech Career Coaching, and Labs by Bincom. Now, under Bincom Academy, Bincom utilizes a Montessori approach to training participants in basic skill needed for the modern technology ecosystem. For Bincom Tech Internship, Bincom is designed to enable people at intermediate level skill to gain skills, mastery, and expertise over a period of time. Bincom Tech Apprenticeship include industrial attachments at various levels to gain experience and on-the-job training. So we also have Bincom Tech Network. This is geared at giving the community, back to the community and building the tech ecosystem. They focus on informing and exposing the youth to current technology trends and how to prepare for future technologies. We have Light Space, which provides helpful workspace intended to encourage collaboration and drive innovation in the startup ecosystem. So we have Bincom Global Tech Program, which is a 1 to 2 year program focused on the 3 pillars, which is learn skill, gain experience, and gain exposure. We have Immigrate Tech Visa, which helps you become globally attractive tech profiles or tech-enabled businesses, and is your tech-enabled pathway to relocation and settling in countries like the UK, US, and Canada, France, and many more. We have the Bincom Mentoring Platform, which is structured at monitoring solutions to help mentors add value to mentees for the purpose of building globally attractive techies. Then we have Labs by Bincom, which is a 3 to 6 months pre-incubation program that brings together participants to build a digital technology product, which will be used in real life, which will be used by real life users. Then we have Bincom Tech Career Coaching, which help individuals to land their next role faster by offering a combination of coaching, relevant on-the-job experience, career referencing, introduction to tech recruiters, hand-holding through application and interview processes, and much more. So Bincom has quite a lot to offer, but these are just the main focus. Thank you. So please, I put a link in the chat box for the feedback form. Please do well to fill the form for us. Thank you. Love to hear from you. I'll also be pasting a link to Bincom programs in the chat box. Thank you. You can continue.
All right. Thank you very much. Thank you. The link to the feedback form is in the chat box. You can do where to fill it. Let's get your feedback and see where we need improvement and all that. And yeah, that's that. So we usually have this section quarterly, and we will have another one again in the next few months. And I hope you will all join as we have learned a couple of things today. So my apologies for our second speaker that did not join. Probably he was not I tried to reach out to him. He didn't respond to my message. I believe the issues with joining earlier probably was one of the reasons why he didn't join us actually. However, we sorry, we apologize again for that. And our first speaker has already the topic by giving us a clear definition and a clear scope on how to run and what observability and monitoring is all about. Thank you very much for joining. See you again some other time. Bye for now.
Thank you. Bye. Hope you see you again. Have a nice day.